All right, now let's look at resolution of vectors. How to resolve vectors. Now, what is the meaning of resolution of vectors? Let's say we have a vector moving a plane, something like this, and we call it vector A. So, this vector is not actually going towards a particular direction. Now, in a Cartesian coordinate, which represents the directions of a plane shape, we have the x and y direction. So this side is minus x, side is plus x, side is minus x, side is minus y, this side is plus y. So if you look at this vector now, this vector is not going towards either x or y, but it's something like between x and y. So what is now the meaning of resolution of vectors? Now, resolution of remember, we represent the vector with a straight line and an arrowhead. The arrowhead will tell us where the vector is going to. Take note of that. A vector, if you want to draw anything like a vector quantity, ensure you put arrowhead. It's very important. This arrowhead is the one that will tell us where the vector is actually going to. So, what is now the meaning of resolution of vectors? Is now when you split this vector now into its respective axis. For example, now if we check, we will discover that this vector is moving towards, if you draw something like this, that is moving towards both x and y. So it's going towards both x and what and y. So to get the s and y component now, we use resolution of vector. So resolution now means we should move this vector, we should calculate the amount of this vector to the x and also calculate the amount of this same vector to the y. That is the meaning of resolution of vector. What amount of this vector A is going to the x and what amount of this same vector A is going to the y. That is the meaning of resolution of vectors. Now, I can define resolution of vector as the splitting of a vector into its components. Into what? Its components. Now, what is the meaning of component of a vector? Is the amount of that particular vector going towards a particular direction. So the amount of vector A now to the y direction is the y component of A. The amount of A going to the s direction is the s component of A. So that is the meaning of components of a vector. Now, how do you get that component of a vector? The first thing, you must know the direction or the angle between that vector and the x-axis or the y-axis, as the case may be, which is theta. The angle must be known. Then the next thing is for you to now start resolving the vectors. Now, how do we resolve these particular vectors now? So let's go. The first thing is to get the s component. S component. Now, what is the s component of this vector? It means what amount, remember this horizontal side is the x. Take note of, here is the x, here is positive s, here is negative s, here is the y. Then here is positive y, this side is negative y. So take note of that. It's very, very important. Then remember, okay, we already denoted that. So s component means the amount of A now going to the s direction. So how do you do that? Look how to do it. The first thing you check in the right hand side, check in the right hand side, s is positive. Then in the left hand side, s is negative. Look at it. In this side, s is negative. In this side, s is positive. Then you check whether the s is in this right hand side or the left hand side, whether the vector is in the right hand side or the left hand side. So let's check where the vector is. It's in the right hand side. Check, it's in this side. That's it. So s will be positive. So the s component of A now, you just write ax will be equal to plus, because it's in the right hand side, that'll be plus vector A times cosine of the angle between A and the s axis, which is theta. That's how to get the s component of A. Now, how do we get this cosine of this angle? You can get that from Pythagoras theorem. I don't want to be proving that now, although it's not hard. It's not hard. You just draw something like this, draw something like this. Use Sukatua. You can use Sukatua to do it. The theta is here. Then this one is y axis, this one is s axis, and our a is here. So cos theta will just be cos is opposite of our hypotenuse. That is adjacent to our hypotenuse. That is cos, which is then sine is opposite of our hypotenuse. So we just get your y and s axis. As we make s and y set formula, it's called that s is a cos theta, y will be a sine theta. That's why we do get that from. But you don't need the proving. That's why I don't prove it. What you just have to know is that if the angle is subtended to the s axis, take note, the angle must be between the vector and the s axis. Very important. Before this mode there will work. So if the angle is between x and y axis, and you want to use this same mode there, remove this angle from 90 so that we come to the s axis. Just remove the angle from 90, then you come to the s axis before you start doing anything. Or else reverse will be the case. Then let's look at the y component now. The y component of A. The y component of A will be equal to, so let's look at the y component of A, vector A will be equal to AY is still the same y. Amount of A going to the y axis now will be we have gotten the amount of this vector going to the x. Now let's look at the amount of this same vector now, because it's between s and y. Look at the amount going to the y now to see what we're going to do. The same to check in the y axis. Look at this. Y axis like this, then intersected by x. In the upper side, y is positive. In the downside, y is negative. So you check if the vector in the upper side or in the downside. Actually, this vector is in the upper side. So what I'm going to do, we'll just put positive for y. So y will be positive. We have positive y. Then the next thing now, you now use this vector A to multiply. Instead of cos, you now use sine of the same angle between A and x. The same angle. Don't change the angle. Just change your cos to sine. That is all. So for x axis, you use cos. For y axis, you use sine. That is all. I hope I'm communicating. Yes, I'm communicating. Now, so the next thing now is, let's look at how to represent these vectors in rectangular form. Look at how to represent the vector in rectangular form. Remember, we can put I here. Remember, s axis in vector means I axis. Y axis means G axis. In vectors, S means, and anytime you see I, it means S axis. Anytime you see G, it means Y axis. So take note of that in vectors. Now let's look at how to represent these vectors. Now this is in component form. AX, AY is in component form. Now let's go how to move this from component form to rectangular form now to see what we're going to have. Now we already established that AX, for what we're doing, is equals to A. Okay, let me use small letter, right? A cos theta. Then AY is equals to A sin theta. Now let's check. Remember, we can put I here. We can put I here for S. We can put G for Y. Don't forget that. Now, how do we now represent this same vector in rectangular form? How do we represent this same vector A in rectangular form? Let me just use capital letter A. Let me change it to capital letter. How do you now represent this vector A in rectangular form? Because this one is in component form, S and Y component. Now in rectangular form now, the same vector A will now be equal to, you will check this answer. Is it positive or negative? It's positive. So the next thing, remember this and this are the same. So the next thing I'm just going to do now, we just write AX. Instead of using this side, you will use this side of it. Look at it. For rectangular form now, look at the meaning of rectangular form. Instead of you using this side, just write it in this other side, which is AS and AY. So you just say vector A is equals to, since AS is positive, just write AX. Then to denote that AS is to the S axis, you put the unit vector there, I. Then you check Y. Y is still positive, plus the same AY G. So this one now, this is the rectangular form of the vector. If you just write the answers you're going to get here, I, write this other one, J, that is the rectangular form. Now let's look at how to represent it in polar form. The same thing in polar form. Now in polar form now, vector A will be equal to, instead of using this other side, you will just use this side. That is the polar form. Rectangular form, you use this side. Polar form, you use this side. So you're going to have something like this. We're going to have A for polar form cos theta I plus A sin theta G. This is the polar form of A. Now, this must not be positive. This depends whether this rectangular form, this component form is whether it's positive or negative. You get everything from component forms. If it's positive, this one will be positive. If it's negative, this other one will also be what? Negative. So this is the component form. You find AS, you find AY. That is component form. Rectangular form, the AS and AY you are going to get, combine the two together. Then for S you put I, for J you put, for Y you put J. That is the rectangular form. Then the polar form is just for you to just write the vector A cos of the angle between them and plus vector A sine of the angle between them. It's just for you to write. Don't write the answer out. Just write it in the form. That is the polar form. Now look at another way to represent polar form. Look at another way to represent polar form. The polar form can also be represented this way. Vector A will be equal to A to the angle of theta. You can still represent polar form this way. This one means that A cos theta I plus A sin theta G. That's the meaning of this. In case you see this anywhere in physics, know that it is a polar form of vector A cos theta I plus A sin theta G. For example, if I ask you now, if vector A is equals to, let's say 3 to the angle of 30 degree, I say what is the actual form of this, or rewrite this one? You just tell me A is equals to 3 cos 30 I plus 3 sin 30 G. So you calculate and just press 3 cos 30, write it here. 3 sin 30, write it there. That's how to, if you just do this, you convert it into rectangular form. The answer will move to rectangular form. So this is the S component, y this is the y component. So if you find this answer now from your calculator, and the answer is not either in, when the answer is no longer in cos and sine, automatically you have moved to rectangular form. But if you separate the S from the y, you have moved it to component form. So that is just it. I will just show you a little example. Let's just go first. Then next is to get the magnitude of A. To get the magnitude of A. To get the magnitude of A, we get it from the rectangular form. Remember, in the rectangular form, we say A is equals to AXI plus AYJ. Remember this. So the magnitude of A now, we did denote it this way. Something like this. Is always equal to the square root of the S component, the coefficient of I. Then you square it plus the Y component, then square it. Now, whether S or AY or AS is positive or negative, for magnitude, it must be positive. Because if you take the square root of a minus sign, let's say we have minus AY now. If you take the square root of that, this, if you take the square, not square root, if you take the square of a minus sign, automatically it will change to plus. If you take the square of minus, it will change to plus. That is why I don't tell students to add minus or plus to the magnitude. Because most of them may not know how to operate with minus. Just use plus throughout, you still get the same thing. That's why I do tell my students. So take note of that. It's very, very important. So this is how to get the component, the magnitude of A. That you do get it from what's it called, the rectangular form. Now, how do you get the direction of A? Now, to get the direction of A depends on the quadrant in which A is located. the quadrant in which the vector A is located. We have the first quadrant, second quadrant, third quadrant, and so on. Now, if let's just do just only one, look at it. If AX and AY are both positive, take note of this. So if AX and AY are both positive, the direction of A will be the tan inverse of AY over AX. This is if AS and AY are both positive. If both AS and AY are not positive, we'll use other means to get the direction. But this formula will still show up in all. This formula will still show up in all. It's just that we'll just be, for example, now, let me show you what you are trying to say. Let me show you what you are trying to say. Let me just give you something, a clue, before we move forward. Look around, look at what I'm trying to say. Remember, this is the vector A, which is theta here. And this is the vector A we're looking at. See, I'm telling you that if the vector is here, and that is just the angle, angle can either move like this or like this. Any angle that is anti-clockwise is always positive, while an angle that is clockwise is always negative. We did that in complex number. Now this and complex number is almost the same thing. It's just that in complex number we do have real and imaginary, but in this relation of vectors we do have s and y axis. That's just the difference between the two, but the same procedure is used. If you want to get the magnitude of a complex number, the same thing you do. Just square the real and square the imaginary and take the square root of everything. You still give it the magnitude. So I don't want to do so many hard things here. So just take note of this one side first. I also know that each angles we have two types of angles. We have the negative angles and the positive angles. Now, negative angles are always clockwise. Positive angles are anti-clockwise. Now, there is an angle that is always, for example, if I say 30 degrees, there's a negative angle that is equal to 30 degrees. That's what I'm trying to tell you. One negative angle equal to 30 degrees. How do you get that? You will remove this 30 from 360. The answer you are going to get, if you take the negative of that answer, you are going to get the same angle with 30. Everything 30 is going to give you, that same angle will give you that answer. But we don't want to go into this angle theory now. Let's just look at how to calculate this theta. If you want to calculate this theta now, just use the tan inverse. Tan inverse of theta will be equal to that theta. This theta will be equal to tan inverse of AY over AX. What about if the A is not here and you want to get this angle? Face it. The next thing now, if you forget this one, theta, then you remove it from 180 to give you this other one. That's what I'm trying to say. Then you start using the rules of geometry. Look at it. If the stuff is not here, for example, now, the first thing now, this formula will be able to give you this angle. That's what the formula will give you. But the one you are looking for is this one. The angle to the positive x-axis, that is what you are looking for. So for you to get that angle now, after you are getting this theta, we just remove it from 180, which is angle of a straight line. Then you get this other one. Let me even call this one. Let me call this one alpha. For you to get this theta now, just remove alpha from 180 to give you theta. Now what about if the angle is here? What about if the angle is not here? If the vector is not here, this formula will be able to give you this angle. It must be to the x-axis. That is what this one will give you, which is y over x. Tan is opposite over adjacent. Then if you want to get this one, look at the one we are looking for, to the positive x-axis. That's what we are looking for. To get it, if you get this first one here, just add it to this full angle of a straight line. If you add it to 180, you get this other one, just theta 2. Then what about if the angle is not here? What about if the vector is not here? You can either get it this way or you get it this way. That's what I'll tell you just now. We have clockwise and anti-clockwise. So if you get this particular one, it's not the same thing as this. That's one thing you should take note of. So you must start like this. You must move in anti-clockwise direction for the angle to be positive. Now, if you move in this, you must start from the x-axis, positive x. You must start from this positive x. That's one thing about vectors. So to get angles of a vector, you have to practice it. Although maybe I will do another class on these angles of a vector. Let's take care of that. So for this last one, now what you do, first you get this one. After I've gotten that, you just, to get this one now, you remove this one from 360, because angle of a cycle is 360. Then you get this other one. So that's how the thing is. So we'll do that later with maybe another class. Now let's look at a few examples now. A few examples. For example, now let's say we have a question. What is the component of this vector A? And the A is 10, making an angle of 60 degrees to the x-axis. So what is the component of this one? Remember I told you we have the x component and y component. To get the x component now, we are going to have 10. Remember ax is equals to a cos theta. Ay is equals to a sin theta. Remember that. Don't forget that, please. So the next thing we're going to do now is just come and apply the formula. We have 10 cos, what is theta? Theta is 60. You have an answer. Then ay will be equal to 10 sine 60. Then we also have an answer. That's ax and ay. So 10 cos 60 going to give us 5. Y 10 sine 60 will give us something 5 root 3. 5 root 3. 5 root 3. Or it can also be 8.7. So these are the x and y components of these particular vectors. Now why are both of them positive? Because it is in the right hand side and it's also in the upper side. In the upper side, y is positive. In the right hand side, s is positive. That's why both vectors are positive. So take note of that. Now, for example, now these are the components. These are the components of this vector. That is the answer to the question. The answer was just ax equal to 5, ay equal to 5, 8. Let me just 8.7. 8.7. That is the answer. Now, if I tell you what is this, represent this answer in rectangular form, you tell me A is equals to AXI plus AYG. ASI plus what? AYG. That's how to represent the answer. The same answer in rectangular form. Look at it. It is the same thing as AX is 5. AY is 8.7. G. This is how to represent the answer in rectangular form. Then in polar form, look how to represent the answer in polar form. How to represent the answer. You don't even need to calculate anything. Just got to write. You just write the magnitude, then to the angle of what. That is all. Remember the magnitude was 10 before. It was 10 now. Should we check it? Remember to get the magnitude of a vector. Okay, let's check now to see. Let's check and see the magnitude so that you see it. Magnitude is 10. So what is the magnitude of A? It will just be the square root of AX. That is the coefficient of I axis, you square it, plus AY, coefficient of J axis, you square it. That will be the square root of 5 squared plus 5 root 3 squared, or you just use 8.7 squared. So you are going to have an approximate answer. An approximate answer that will be equal to 10. That is from the question. We're given the magnitude to be 10. So if you want to represent this vector now in polar form, you just write this magnitude of A. You write the magnitude of A, which is 10, to the angle of what? Remember the angle was what? 60 degrees. This is how to write it in polar form. Simple as ABCD. So the components are 5 and 8.7, the x and y components. Now let's look at another question. Okay, let's look at this question. Another question. The components of vector B are given as follows. Bx is equals to, now this is how we do give vectors in their component form. Bx equals to 3.5. By is equals to 2.1. Find the magnitude of B and the angle between Bx, okay, and the angle between B to the positive x-axis. Find the magnitude of B and the angle between B and the positive x-axis. Remember, the magnitude of B will be the square root of Bs squared plus By squared. That will be 3.5 squared plus 2.1 squared. So if you do this with your calculator, 3.5 squared plus 2.1 squared, you're going to have approximately 4.1 as the magnitude of B. This is the magnitude of B. Then they can now ask you, okay, another one is, what's the direction between vector B and the positive x-axis? All right, remember we said the magnitude of A, okay, the magnitude of B is equal to 4.1. So if I remember Bx is 3.5, By is 2.1. So if I ask you now, where's the angle between this B and the positive x-axis? You check Bs and By. Are they both positive? Yes, they are both positive. So you can use this formula, tan inverse of By over Bs. That will be tan inverse of 2.1 over 3.5. And that is going to give us something approximately 31 degrees. Now to present this answer in polar form now, I just say vector B has a magnitude of 4.1 to the angle of 31 degrees. This is how you can present it in polar form. And if you solve this one again, you have this Bx, By back by taking 41. You want to check whether you could just say 4.1 cos 31. If you give you this 4.1 sin 31, must give you this back for both s and y components. So let's look at another question. Find the sum of the two vectors. Another question. Find the sum of the two vectors 6 meters to the angle of 30 degrees, and the other vector is 3 meters to the angle of 150 degrees. So what's the sum of these two vectors? If you add them, what are you going to have? Now look at what we are going to do. The first thing, let's call the first vector A, which is 6 meters to the angle of 30 degrees. Let's call the second vector B, which is 3 meters to the angle of 150 degrees. The next thing is, what is A plus B? That is the sum. Sum means add the two together.
That is mean of sum. You say find A plus B. We cannot add directly from here because this is polar form. We cannot add like this. We need to move this one to rectangular form before we can add. How do you move this to rectangular form? Remember, we have done it before. It will now be 6 meters. Then 40 cos of this angle, cos 30, plus 6 meters again, sine 30. So that's what you have to do. That's what we need to do. So 6 meters sine 30 before we add. So let's do it one after the other. So let's go. We're going to have 6. Then you take the cos of this angle, cos 30. Then for this one is the x axis, you put I. Because we are using cos for x axis. Plus the 6 seems again. Then for y now, sine 30. Then this one is for y, put j. So what is 6 cos 30 and 6 sine 30? So if you do 6 cos 30, you're going to have 5.2. This one is for the s, you put I. Plus you do 6 sine 30, you're going to have 3. This one is for y, you put g. Then for the second vector b, which is this one, we said this one is a now. This other one is vector b. So b will be 3 cos first. Cos. Look at it. The first thing first, take 3 cos 150. Plus again 3 sine 150. Then let's see what we are going to have. Now for the second vector b, x 3 meters to the angle of 150. So for the this one now is going to be 3 cos first 150. This one is for x. Plus that's how to interpret this polar form. This one, what I'm writing now, they are the same. 3 sine 150. Then this one is for y axis. Then you put j. Then you're going to have the first one will be minus this one. If you do 3 cos 150, you're going to have minus 2.6 I. If you use 3 sine 150, you're going to have 1.5 g. This is what you're going to have. Now, this is for b. So our a is equals to 5.2 I plus 3j plus 3j. B is equals to minus 2.6 I plus 1.5 g. So what will now be a plus b? What will now be a plus b? A plus b will be this plus this. And how you going to add it? You will add I to I, then you add j to j. That's how to add vectors. Come on, I'm trying to say. We are going to have 5.2 I plus 3j. This one is a plus b, which is minus 2.6 I plus 1.5 g. So the next thing now, you add I to I, you add j to j. So let's do the addition now. So you add I to I, J to J. But first, let's open the bracket first. So we're gonna have, there's nothing here. Open the bracket, remain the same. What is this one? It remains the same. That is 5.2I plus 3J. Then the same thing, there's nothing here. It's just plus that's there. So if the bracket remain the same, that is just plus 1 times minus 2 will still be minus 2. That's minus 2.6 I plus 1.5 G. Next thing, you add I to I, add G to G. You're going to have 5.2 I minus 2.6 I plus 3G plus 1.5 G. So what are we going to have here? If we do this, 5.2I minus 2.6I. So if you subtract these two, you're going to have 2.6I. Then if you add this to this, because this one is negative, that's why you're subtracting. Plus times minus will still be minus. That's why it's like that. Plus times plus is plus. So that will give us 3G plus 1.5G. That will be 4.5G. So this is the answer for A plus B. So that's the answer we're looking for. That is the sum of A and B. The first thing you do, you move the vectors to rectangular form. Then you add I to I, J to J. That is all. It's not this long. Because I'm just explaining, that's why it's as long as this. So let me just, okay, now remember the question was presented in polar form. This one is rectangular form. This one is showing IJK. It's a rectangular form. The one that is showing, let's say AX, AY, that is component form. Then this one that is showing this one, let's say A slash theta, that is in polar form. Now the question was given in polar form. So let's move this rectangular form now back to polar form. Let's just try and do that. Although this is correct too. This is correct. But let's move it back to polar form because they might present the answer in polar form. So let's just do that. So to move this answer now to polar form, the first thing we're going to do, we're going to get the magnitude of A plus B and the direction. That is all. Let's not forget the magnitude. Remember, magnitude means square. AS square. What is AS? AS means the coefficient of I. That's AS. Go and check again. That's 2.6. You square it. Then plus coefficient of J is AY, which is 4.5. Then square it. This one is going to give you 5.2. So you're going to have there. Then the direction theta to the positive S axis will be tan inverse of, check, AS is positive, AY is also positive. So that formula will still work. AS over AY. So which one is the Y axis? For the Y axis side. The one that is with G, that is the Y axis side. That's 4.5 over the S axis is 2.6. This will give you approximately 60 degrees. So the answer now is that the final answer now, A plus B in polar form, will be the magnitude, which is 52, to the angle of 60 degrees. So this is the answer in polar form. This is the answer in rectangular form. So this is how you move it to polar form. This is it. If you solve this one out now, if you do 5.2 cos 60, you have going to have 2.6 as the answer. Just try it. Just try and do. Move this one back. To move this one back to rectangular form, just do 5.2 cos 60. That's for I. Don't forget to put the I. Then plus 5.2 sin 60. That's for G. So please take note of that. It's very, very important. So last question. Now let's look at this question. Given that vector AX is equal to 3.7 and vector AY is equals to minus 3.1. find the angle. Okay, find the magnitude of A and the angle between vector A and the positive s-axis. And the angle between vector A and the positive s-axis. So let's do this now. Remember, for magnitude of A, let me just do this one first. It will be the square root of what? AS squared plus AY squared. So which one is AS? 3.7 squared plus AY. I told you don't use minus. Even though you add the minus 1 point squared, this minus will change to plus. So don't go and add it, just leave it. Just take only the value. So 3.1 squared. So I'm going to have an answer. So I'm going to have 4.83 or 4.8. Then the direction theta. The direction theta is going to be, check, AS is positive but AY is not positive. So the direction theta cannot just be that. It's not possible. To get the direction now, you can only use theta is equal to tan inverse of AY over AX. If both AS and AY are positive. If they are not, you cannot use this formula directly. So look at what I'm going to do now. We are going to draw it out. We're going to draw it out. AX is positive, so it's going to be in this right hand side. So that's why we have AX, which is 3.7. Then AY is what? Negative. Upper side is positive, downside is negative. So AY is in the downside. AY is in the downside, which is 3.1. Don't go and put negative again, because that negative is telling us that it's in the downside. That's why this negative sign is saying that it's in the downside. So the next thing we are going to do is to get the angle between the vector E, not AS or AY. Vector A will be acting at somewhere here. So will be vector E. So what we are looking at now is this angle, which is theta. To get that angle, I already told you guys that you get this one, then you remove it from 360. We'll give you this other one. That's just how the thing is, because the what's it called? What will I call it now? The angle of the cycle is 360. So if you just remove this small one that is here to give you the final angle, that's just that. So that's how to do it. So I will just give you guys a little shortcut to this, so that it will not be too hard. Let me just give you a little shortcut to this. If you know this shortcut, you're already good to go. Now, this shortcut will give you positive angles only, not negative angles. If you want to get the negative angles, the answers you are going to get now, just remove it from 360, or just remove 360 from them to give you the equivalent negative angles. Now, see, listen to it too. Okay, take note of this, what's it called, magnitude. I want to just take note of that one, magnitude. And listen, if I could get theta, which is direction, theta will be equal to, number 1, tan inverse of A y over ax. Now this is possible if ax and ay are positive. That's when this formula will be possible. No, but that is the first one. No. Second rule, rule 2. If as, let's say we have as to be minus, then ay plus. If both of them are positive, use that formula. But if as is minus, then ay is positive, then theta will become, just write it down. If as is negative, then ay is positive. Theta will become 180 minus tan inverse of ay over ax. This is possible if AS is negative, then AY is positive. Then that is root 2. Take note of that as well. Then root 3. Root 3. If AX is positive, okay, let's do this. Let's do this other one. 4.83. If AY is negative, then AS is also negative. Both of them negative. Theta will becomes 180 plus tan inverse of AY over AX. It is possible if both AS and AY negative. Take note as well. Just take note of them. That is all. Then lastly, the last one is, there are 4 numbers. The last one is, if AS is positive, then AY is negative. AS is positive, AY negative. Like this, the case of this question now. Theta will be equal to 360 minus the tan inverse of AY over AS. This is how it is done. These are the 4 rules you use. You want to calculate the angle of a vector between a particular vector to the positive s-axis. So all these angles now I just showed you is between the particular vector to the positive s-axis. So let's do this now to get the answer out, because in this our case now, AY is positive, then AX is AY is negative, then AS is positive. Remember rule 1, if both of them are positive, theta will be tan inverse of AY over AX. That is first rule. Rule 2, if AS is negative but AY is positive, theta will be 180 minus tan inverse of AY over AX. Rule 3, if AS is negative, AY is negative, that means both of them are negative, theta will be the tan inverse, okay, 180 plus, now not minus, plus the tan inverse of AY over AX. Then the last rule, if AS is positive, AY negative, which is what we're having here now, theta will be 360 minus the tan inverse of AY, which is 3 point, don't add the sign though, please don't add the sign to it, 3.1 over 3.7. Why are we not adding the sign? Because it's the sign that is telling us do it this way. What am I using to get the answers now? Is it not the sign? I'm using the sign now. It's the sign that is regulating the angles. I'm telling you, if the signs are positive, theta will just be tan inverse of AY over AS. If AS is negative, AY is positive. I'm using the sign to get them now. So the signs are already telling us what to do. Minus from 180, add to 180, minus from 360. It's the sign that is telling us those ones. So don't go and use the sign again if you want to solve all these things, so that you don't have issues. So if you do this now, what are you going to have? So this will give us approximately 320 degree. So this is the angle between vector A and the positive axis, and this is the magnitude of vector A. If you want to put the answer now in polar form, just write this magnitude, which is 4.83. You can just put 4.8 approximately to the angle of 320 degree. Now if you want to get the negative angle of this one now, just remove 360 from this 320 to give you the negative angle. And that negative angle and this 320, they are both the same thing, which is something like minus 40 degree, and 320 to give you the same thing. So this is how we roll here under vectors. So let me just give you one last question now, then we go. Okay, the component of this vector, degree. Let's say the vector is 20. So what is the s and y component of this? The s component, the s component will be 20 cos 30. The y component will be 20 sin 30. Try and see if you can do this on your own. That's why I'm just telling you the answers now. So this will be 17.3, and this will be 10. So this is the x component, and this is the y component. Thank you. Don't forget to subscribe and share to others. Thank you. Also like the video. Thank you.